introduction into antennas, and we'll be studying about the basic antenna parameters. The basic parameters on which the antenna can be justified to work for particular applications will be decided depending upon these parameters. The important parameters on which we can define or else we can understand the performance of an antenna is radiation pattern, directivity and gain, beam area, and effective height and effective aperture. But the other terms like beam area, beam efficiency, effective height, and radiation efficiency, all those are the parameters which are interrelated with these basic parameters. And finally, at the end of the module, we will also be learning about the radio communication link. That is a formula called as Friis transmission formula will be explained, where the Friis transmission formula reveals about how the transmission and reception of the important of the radiations will take place in an antenna. And the last topic of this module will be antenna field zones. Whenever an antenna is placed in one particular location, there are two fields which is framed. One is what we call it as the near field and the other one is the far field. So we'll come to know what are the effects of near field and what are the effects of far field in an antenna when it is placed in one particular location. So in this module, you'll be knowing about the working of an antenna, and we'll also learn about the basic antenna parameters. So starting with the very introduction to antenna, let us first of all we need to know what is an antenna, and then further thereon we can understand about the parameters of an antenna. So an antenna is a type of transducer. It is a special type of transducer which converts the radio frequency signals into alternating current, and also vice versa. It is called as vice versa because whenever the antenna is on the transmitting side, the radio frequency signals which are given by the microwave source has to be converted into alternating current, and that alternating current will be received at the receiving antenna, and at the receiving antenna once again this alternating current and the radio frequency what is there should be converted back into the relevant form whichever it should be portable. So that's why we call it as vice versa. Basically, I can define an antenna is an antenna is a type of transducer which converts the radio frequency signals into alternating current and alternating current into radio frequency signals or as radio frequency fields. And basically, we can classify the antenna into two types. Actually, it is not two types, but we can just call it as transmitting antenna and receiving antenna, because it is not very much conditional that the antenna which is connected on the transmitter and the antenna which is connected on the receiver need to be same. Depending upon the application where exactly we are making use of the antenna, the transmitting antenna and the receiving antenna can be varied. That's why here we call it as basic types of antenna. They are receiving antenna and transmitting antenna. So what is a receiving antenna and what is a transmitting antenna? A receiving antenna is the one which intercepts the RF energy and delivers the alternating current to the electronic equipment. And the transmitting antenna is the antenna which is fed with AC, that is alternating current from the electronic equipment, and generates an RF field. So basically, let us just understand about the definition of antenna. An antenna is a transducer or as it is an electromagnetic device which converts the alternating current to radio frequency signals or as the radio frequency signals into alternating current. And whenever we talk about an antenna system, which is one of the communication system, always it is must and should that there should be a transmitting antenna, and there should be a receiving antenna. So the antenna whichever is connected on the transmitter side is called as a transmitting antenna, and the antenna which is connected on the receiver end is called receiving antenna. And the second important thing is it is not very much conditional that the transmitting antenna and the receiving antenna should be of the same category, because further when we study about the various types of antenna, few of the antenna types are short dipole antenna, lambda by 2 antenna, uh, we have loop antenna, Yaguda antenna, helical antenna, reflector antennas, horn antennas, the plasma antenna, spiral antenna, log periodic antenna. There are several types of antennas like this. There are about 20 to 30 types of antenna. But out of this 30 types of antenna, which antenna will I choose for my application? Suppose if I take an example of a mobile equipment itself, that is the mobile which we go for communication, all mobile equipment will have a antenna which is a bistatic antenna. Means the antenna which is there in our mobile is a short dipole antenna, very short dipole antenna, because the size of the mobile phone is very compact. In that compact device, if I want to implement an antenna for reception and transmission of signal, means when you are making a call using your cell phone, the antenna on your mobile phone should work as a transmitter, and when you are getting an incoming call, the mobile antenna whichever is there in your mobile, that should be working on the reception side. So we make use of a bistatic antenna in the mobile equipment, because the mobile equipment should be able to transmit the energy as well as receive the energy. So in those applications, we make use of a bistatic antenna where the transmitter and receiver are mounted upon the same location. And as the size of the mobile equipment is compact, we should also consider that the space occupied by the antenna in our mobile equipment should be less. So that's why the transmitting antenna and receiving antenna is an important part. Any communication system, to complete the antenna communication system, there is a transmitter and there is a receiver. Suppose if I take one more example of the dish antenna, the cable connections what we get, the cable TV connections. Normally we go for a Tata Sky or some other dish antenna, dish service providers, where they will give a setup box. If the cable operators are there, they'll give a setup box, and through the setup box and by means of a cable connection, cable wire connectivity, you will be able to visualize the channels, that is cable channels. The other way is we purchase a we purchase a dish antenna setup box where they will give the entire setup, that is they will give an antenna, and along with that they'll also provide with a module which has the modulator and demodulator, because the modulator is the one which receives the signals from free space and then it demodulates the signal, and on the transmitter end, that is on the reception end, that is your TV will have the demodulator circuit, and after demodulating signal you can visualize the movie or as the news channels whatever it may be on the TV end, on the television. So the dish setup box is also one type of antenna, that is in the dish setup box, uh, the dish cable connectivity water we get, that comes under the classification of parabolic type of antenna or dish type of antenna. That's why they are called as dish antenna setups by the name itself. So like that, the antenna is one of the important electromagnetic element, or else it is the electromagnetic device which supports for the communication of signals over long distance. And secondly, the communication of the signals takes place at higher frequency. We don't have the antenna is a device, basically it is an electromagnetic device which operates only under the frequency range of radio frequency. That is higher order frequency. Always the antenna starts working in the order of gigahertz. 1 gigahertz will be the starting initial range. So the antennas would be classified as low frequency antennas, high frequency antennas, ultra high frequency antennas, very high frequency antennas, and super high frequency antennas, SHF antennas. So when we have such a wide type of antennas which can work for wider, broader range, we need to decide what type of antenna and which antenna would be suitable for a particular application. Like few of the applications, I give an example, that is the antenna which is there in the mobile phone and the antenna which is used for the cable connections. So in a mobile we make use of a short dipole antenna, or else we just make use of a spiral antenna, and for dish cable connectivity we make use of a dish type of antenna. So this is how, depending upon the application, the type of antenna which we are using will also vary. So the antenna is a electromagnetic device, and also it can be called as a transducer, which converts the radio frequency signals into alternating current and alternating current into radio frequency signal in accordance to where the antenna is implemented. That is, whether the antenna is on the transmitting end or is whether the antenna is on the receiving end. So basically I can call the antenna as a transmitting antenna or a receiving antenna. The transmitting antenna is the antenna where there is an input feed given to the antenna with from an electronic equipment. So this is the AC power supply which will be given, the oscillator power supply which will be given to the transmitter, and whenever the AC input is given, the RF radio frequency signals will be emitted from the antenna which radiates into free space. So on the transmitting end, it is AC to RF, because the signals whichever is emitting out of the device, out of the transmitting antenna, they will travel to free space. And on the receiver end of the communication system, this receiving antenna will receive the radio frequency signals, and this radio frequency signals has to be converted into alternating current, because the output device which we are working will be working on AC concept. So on the transmitter it is modulation, and on the receiver it is demodulation. So if I just take the example of the dish antenna setup, which you people make use for connectivity of cable, the dish works as the transmitter, because it transmits the it receives it obtains the radio frequency signal from the atmosphere, and after modulation it is transmitted over the cable to your television, and on the television we will have the demodulator, and at the demodulator stage the demodulation will take place, and finally you will have the image that is seen on your television. This is how you can understand the basic working of an antenna. And next one is here is the schematic diagram for you to understand about the working of an antenna, or else how the AC signal is converted into radio frequency signal. So this diagram represents the antenna which is on the transmitter end. So this antenna is what we call it as transmitting antenna. Always, as the antennas work at high frequency, that is in the order above megahertz, above around 300 megahertz or 3000 megahertz, that is it is above 3 gigahertz, always we make use of a generator to give a input. a generator, or it is called as transmitter. Normally, we make use of a microwave power supply. In the communication lab also, there will be an experiment which can be conducted on antennas, and for that experiment you will be making use of the microwave power supply, which generates a frequency of 2 gigahertz to 3 gigahertz, and that microwave power supply is connected as input power supply to the antenna. Practically, you can analyze this in your advanced communication lab experiments because there is one experiment relevant to antennas. So, in the generator is normally a microwave power supply, which is a klystron power supply, and operates at the frequency of 2 gigahertz to 3 gigahertz in the lab environment. When the generator is connected to the antenna, this is the structure of the antenna. Here they have taken the example of an horn antenna. It is in the shape like this. This is the shape of the horn antenna. So, through this horn antenna, whenever it is connected to a power supply, that is microwave power supply, the input is given in terms of alternating current, and inside there will be some modulations which takes place, and finally whenever the rays emit outside, it will be RF signals, the radio frequency signals. And normally it is taken into consideration that the transmission line is linear and at the end it is a tapered transition, because whenever the mouth of the antenna is broad or as it is wide open, then the transmission of the signals can take for a larger dimension. That's why normally we take the antenna which has a broader opening. So here in the structure we can understand this is a generator and this is the waveguide which guides the signal, and once the wave is guided, then this is a transmission line, and here we have the transition region of the antenna, and this are the signals which is going to the free space, because the antennas are the devices which is used for longer distance. They are not operable at shorter distance. If they want to operate at the shorter distance, then it is only in the lab applications. Even in the lab, when we are conducting the antenna experiments, we take care such that the distance between the transmitting and the receiving antenna is about 30 centimeter and up to maximum 60 centimeter. This condition must be satisfied, or else on the receiver terminal you will not get the output for this experiment. So the distance is also one of the important parameter. In the lab, when we are conducting the antenna experiment in the lab, we maintain a distance between the transmitting and antenna such that it is either 30 centimeter or up to maximum of 50 centimeter. If I increase the distance, then the output power whatever I get, it will be very less. The output power cannot be detected. It will be zero. The loss will be more. So this is about the structure of an antenna, where the transition of the wave is guided through a structure to the space wave. So we make use of a generator, and from the generator we connect a antenna which is called as a transmitting antenna, and here the AC signal is provided and the radio frequency signals will be allowed to enter the free space. And on the receiver side, so this is the transmitting antenna which is there on the transmitter side, and this is the receiving antenna which is there on the receiver side. This is transmitter and this is receiver. Water signals that is given from the microwave source, they will propagate in the waveguide structure of the antenna, and it is allowed to free space allowed in free space. This is RF signal. And on the receiving antenna, the important property of a receiving antenna is to capture the signals which is available in free space. So this antenna which is on the receiver end will capture, or else it will acquire, or it will absorb, it will the RF signals which is available in free space, and that allows the propagation to the output. So here we'll be measuring what is the output power of an antenna. Even in the lab, we maintain that the distance between the transmitting antenna and the receiving antenna is either 30 centimeter or up to the maximum of 60 centimeter, because we are making use of a strip type of antenna in the lab. But there are also waveguide structures in the lab which is available, which is an on antenna, and we also have a parabolic antenna in the lab. So here, when we are connecting the on antenna or the parabolic antenna, we maintain a distance such that it is greater than 60 centimeter. The snapshots of the devices is also available, which should be shown. So this is the antenna which is framed by means of a waveguide structure, and this is a on antenna which can be aligned in either E field or H field. This is the one of the on antenna which is available in our lab, and this is the parabolic antenna, or which is also called as dish antenna, which we use for disconnections in our home televisions that is connected. And these are the waveguide structures of an antenna. The antenna can also be constructed using the stripline technology. In the earlier sessions of the subject, you people have learned about the microstrip technology. So this is one type of antenna which is a short dipole antenna manufactured using stripline technology. This is a short dipole antenna. So here it is called as a short dipole antenna because it has only two poles for propagation. And this is an antenna which is called as a Yaguda antenna, and which makes use of the stripline technology. And in the lab, you will be working with this microstrip antennas. That is, this is the Yaguda antenna, and this is the short dipole antenna. You will be working with these experiments in your communication lab. And suppose if you want to enhance your knowledge, or else know the suppose if you want to have in-depth knowledge about the antenna concepts, then you can also perform few of the experiments in relevance to waveguide structure also. We have the on antenna in the lab as well as the parabolic antenna in the lab. Just make use of the Klystron power supply as the input power supply, connected to the devices through the microwave test bench, and you can observe the output of this on antenna. You can also derive the parameters of the on antenna and parabolic antenna if you want to enhance your knowledge on microwave on the antenna parameters. But according to syllabus, there are only two antenna type structures which is explained. That is the Yaguda antenna and the short dipole antenna. So in the further classes of further sessions of antennas, the Yaguda antenna, the on antenna, and the short dipole antenna will also be covered. This is only for your information so that you will be knowing how the theory concept which you study in this chapter is relevant to your communication lab. That's the purpose. The diagrams, the snapshots has been shown. So as of now, you have just learned what is an antenna, what is the basic types of antenna, and the working of antenna. Just as a revision, the antenna is a special type of transducer which converts the radio frequency signals into alternating current, and also vice versa. Basically, we can call the antenna as transmitting antenna or the receiving antenna. The antenna which is connected on the transmitting end is called as transmitting antenna, and the antenna which is connected on the receiving end is called as receiving antenna. The main performance of transmitting antenna is the transmitting antenna will be given an input feed from a micro power supply. So there is an alternating current which is traveling in the waveguide, and finally it emits and gives the generation of an RF field, that is radio frequency signal. So the transmitting antenna will radiate the RF signal into free space. And on the receiver end, what are the signals that has been radiated to free space? That will be detected on the receiver end, and on the receiver end there is a demodulation process which takes place. So on the receiver, the radio frequency signals are received, and then demodulation process takes place, and finally the RF signals are converted into a alternating current at the receiving antenna. So this is about receiving antenna and the transmitting antenna. And next, the transition of the signal in a waveguide structure. So it consists of a generator, it consists of a waveguide structure. Normally when we are considering the antennas, we try to go with a waveguide structure which is a closed loop structure, because when the signals are allowed to propagate for a longer distance, the wave will have higher strength for transmission. So for that purpose, we make use of a transmitting antenna.